Hello folks, welcome to part 2 of identifying organic molecules based on functional group. We're going to go through a few more functional groups and then we should be good to go on moving on to our spectroscopic analysis. First off, we have got, folks, we are going to start with part 2 of our identifying organic molecules based on their functional groups. I've got a few more to introduce and then we should be good to move on to using them in spectroscopic analysis. First off is haloalkanes. Haloalkanes are basically an alkane, but with a halogen attached right here. In this case, they are halogens are anything in group 17 of the periodic table. That is iodine, fluorine, chlorine, bromine, etc. And they're named using prefixes fluoro, chloro, bromo, iodo. This one being chlorobutane. If the chlorine had instead been right here, this would be a 2-chlorobutane. Here would also be a 2-chlorobutane. Diols are basically an alcohol, but it's got, instead of one hydroxyl group, it's got two, here and here. They need, when you are naming these, you need to identify the position of the two hydroxyl groups. In this case, it would be propan 1,2-diol. Propan because it is a propane-based molecule, base carbon chain, and then 1, 2 are the two positions of the hydroxyl groups diol. Aldehydes. Aldehydes have a double bonded oxygen bonded to a carbon, but they are not an acid. That's the other thing that's got that because they don't have hydroxyl group. It's always attached to an end carbon. So at the very end of the carbon chain, could be a side chain though. And they have a -anal ending. And this one is propanal. Prop because it's 1, 2, 3 long, anal because of the aldehyde C double bond O. Not to be confused with ketones, which again have a carbon compound with a C double bond O, but in their case it is not on the end, it is instead somewhere in the middle. It's never attached to a terminal carbon. They have a -one ending, this one being butan-2-one. It's a little bit tricky to tell the difference between a ketone and an aldehyde. Just got to remember that ketones have their carbon bond, the carbon to oxygen bond in the middle, aldehydes have it on the end. And that's it. That's all the carbon compounds, all the functional groups that we've got for the moment.